Hello everyone. In this lesson we're going to take a closer look at electrons. We know about the nucleus of an atom. We can find the mass number, protons, and neutrons with the atomic number and mass number. Now we want to talk about how those electrons are arranged. So we know the electrons have a negative charge. They're located in a cloud around the nucleus and they determine the properties of the atom. Now we're going to focus a lot on the properties later when we start talking about chemical reactions and groups on the periodic table. For now, we want to figure out how those electrons are arranged. And you may have noticed when you were building your atoms that you could never put more than 2 electrons on the first ring, and then the simulator only went to 8 on the second ring. But that's all that would fit there. And then we start getting more electrons as we get further from the nucleus. Because remember, electrons repel each other. They have a negative charge, so you can't cram a bunch of them into a little space. And there is, in fact, empty space between electrons. Most of the atom is empty space. The nucleus is a tiny, dense, massive center of protons and neutrons, and then the electrons are zipping around in pretty much empty space around the nucleus. Now, this is a model of a neon atom. A neon atom has 10 protons and it has 10 electrons. The first energy level, that's this first ring around a neon atom, can only hold 2 electrons. And so that's 1 electron, 2 electrons, and then the next 8, because remember this neon has to have 10 protons, and so then 10 electrons. The next 8 electrons are in this second energy level. If we wanted to go one more atom on the periodic table, we would actually have to add a proton, and then our next electron would actually end up out here on another energy level. So if we exceed 8 electrons on the second energy level, then the third energy level comes into play. So electrons will fill lower energy levels first, and then as the lower energy levels fill up, they will start filling higher energy levels. So we want to draw the complete electron dot diagram for hydrogen. Hydrogen 1, remember when we're talking about a specific isotope, we name it with its mass number. It says be sure to include the subatomic particles in the nucleus. First thing we should do is figure out what all of those are. So hydrogen has 1 proton, so I'm going to go P plus is 1. Because it's got 1 proton, it's got 1 electron, so 1 electron. And then our number of neutrons, they remember have no charge, that would be 1 for its mass number, minus 1 because it's got 1 proton is 0. So mass number 1 for hydrogen 1 tells me I've got 1 proton. So in the nucleus, I'm just going to put P plus equals 1. I'm not going to draw circles down there. That gets too hard to count. And then on my first energy level, I'm going to put 1 electron. There's the complete electron dot diagram for hydrogen. It shows me how many things are in the nucleus, and it shows me on what energy levels the electrons are placed and how many are on that energy level. Let's look at maybe a little bit more complicated example. So draw the complete electron dot diagram for nitrogen 14. In order to do this, I have to have a periodic table. I look up nitrogen on the periodic table. I see that it is element number 7, so it has 7 protons. Because it has 7 protons and every proton attracts an electron, it will also have 7 electrons. And then the neutrons I get by taking the mass number 14 and subtracting out the protons 7, and I end up with 7 neutrons. Now, for some reason, students like to tell me the protons and the neutrons have to match. That's entirely false. On nitrogen 14, they did, but they don't have to. So then I come in here and I'm like, all right, there are 7 protons and there are 7 neutrons. And then I'm going to put my electrons in. So I put in 1 electron, then I put in 2 electrons, and then I'm going to move to the next energy level. I need a total of 7. So there's 3, 4, 5, 6, 7. Now I want you to look at how I actually filled in those electrons. I didn't randomly place them. I started my electrons and I put them opposite each other on that first orbit or energy level. And I did that because the electrons are going to move apart from each other. They're the same charge. They don't like each other. And then I started putting them on the 12, 3, 6, 9 o'clocks. And then after I did that, I paired them. And that is a good trick for you to do. Don't randomly put these electrons anywhere. Well, in real life, they can move in lots of different places around the atom. It will help you later, and it'll help me grade, if you put those electrons in pairs. So first do 1 all the way around at the 3, 6, 9, and 12 o'clock positions, and then if you need to start doubling them, put pairs by them. And that'll make more sense when we start talking about orbitals and how electrons are actually arranged within the energy levels. All right, one more. We've got aluminum 27, and so we look up aluminum on the periodic table. Aluminum is element number 13, so that tells us it has 13 protons. That means it's got 13 electrons. And we also know that the number of neutrons is given by 27 minus 13, which is 14. So in my nucleus, I have 13 protons. I have 14 neutrons. That gets me my 27 particles. And then I'm going to put in my first electron, my second electron, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11, 12, 13. Okay, and so now I can see that I've got an energy level that's full with 2, my next energy level is full with 8, and my last energy level has 3 for a total of 13 electrons to balance my 13 protons. If there's no reason to put electrons on an energy level until we have filled the lower energy levels. On your worksheet, some energy levels will be empty. Those energy levels exist, but we only care about them if electrons are actually occupied.